Gang, I have to reshoot this. I screwed up the video. So for this one, cosine is continuous for all real numbers. This has a domain restriction because what's under the radical has to be positive. So if you add these together, overall this function, the domain of this function, it will only be from 0 to infinity because of this guy. And this function is continuous on its domain. This function is continuous on its domain. So adding them together makes them continuous on their domain. It's just that their domain is from 0 to pi. Sorry, 0 to infinity. This one has the greatest integer function, and as long as it's a standard greatest integer function, it'll just jump at the integers. So it's going to be discontinuous at every integer because there'll be a gap there, and the gaps are non-removable. You can just write it like this on the test. That's fine. If you want to use that fancier notation, you can use that too. The k plus 1, k plus 2. That's fine as well. For this one here, when I plugged in 1, I got 0 over 0. And so there's a hole, because it's 0 over 0, there's a hole in this one. And I was trying to see if they were plugging the hole with the second part of the piecewise function, but I had to figure out where the hole was. So since it's a quadratic over a linear, what that creates is a linear, but this linear has a hole, and I was trying to figure out where the hole was. So the hole, if you do this, if you work this out, you factor this, you cross out where the hole is, it leaves you with 3x plus 2. You plug in the 1, which is where the hole is. The hole would be at 5. So the hole's at 1, 5. So then they come along and they say, well, at 1, use a height of 0. So that didn't plug the hole. We still have the hole, so it's still discontinuous. So this is a discontinuous function. At x equals to 1, and that's because it's got a hole which is